Paper 15. Right. Question number 1. Yes, given that P greater than Q greater than 0, Fx given x squared minus 2px plus q squared. Gx given x squared minus 2qx plus p squared. Show that the roots of the equation fx equals 0. Right. Fx equals 0. Equation, let's see what. Fx is this, no? Right. Then we can write fx x squared minus 2px plus q squared equals 0. Its delta b squared. B is minus 2p. P squared minus 4 times a is 1. C. Delta here 4 p squared minus 4q squared. Delta, take 4 out. P squared minus q squared. This you can write p plus q into p minus q. P and q both are positive. P greater than q. So therefore this also positive. Then this whole thing positive. Therefore delta positive. Delta positive means delta greater than 0. Therefore roots of fx equals 0 are real. Real and distinct, because delta x 0, no, or delta x positive, no, real and distinct. At delta x positive, roots real distinct. Delta x 0, real coincident. Delta x negative, imaginary. Okay. All right. So then, secondly, we'll take gx equals 0. Gx equals 0. Our gx is x squared minus 2qx plus p squared equals 0. It's delta. Then b squared is minus 2q of x squared, b squared minus 4 times 8 times this p squared. Delta here 4q squared minus 4p squared. Then here we have q squared minus p squared. 4 times q minus p, q plus p, like this. This is positive. Reason both p and q are given as positive, no? Q minus p. Q smaller than p, then q minus p is negative. This is negative. Therefore, delta negative. Therefore, the roots are imaginary. Okay. Therefore, roots of gx equals 0 are imaginary. Right. Now, next one given. Let the roots of fx equals 0. Fx equals 0. X squared minus 2px, x squared minus 2px plus q squared equals 0. Roots are alpha beta. Alpha beta. Then we can write alpha plus beta minus b upon a. A is 1, no? Then 2p alpha beta q squared. Okay. Right. And gx equals 0, roots given as gamma delta, no? Gx equals 0, roots given as gamma and delta. X squared minus 2qx plus p squared equals 0. Its roots are gamma delta. Then gamma plus delta 2q gamma delta p square. Now it's asking there, should I the quadratic equation whose roots are alpha gamma beta plus beta delta and alpha delta plus beta gamma is given by this. All right. We know how to write the quadratic equation when the two roots are given. We know how to write the quadratic equation when the two roots are given. The two roots given are alpha gamma plus beta delta, alpha delta plus beta gamma. Then the equation we can write x squared within the first bracket, sum of these two roots x plus product of the two roots. There we can write alpha gamma beta delta into alpha delta beta gamma equals 0. This is how we write the quadratic equation when the two roots are given. Now we can simplify here. Here by these two terms we can take alpha out, gamma plus delta. By these two roots we can take beta out, gamma plus delta times x. Here alpha squared gamma delta, this and this, alpha beta gamma squared, this and this, alpha beta delta squared, this and this, beta squared gamma delta equals 0. X squared, take this plus delta out, times x. Okay. Then here we can simplify furthermore. Here this term and this term you can take gamma delta out. Within bracket we get alpha squared plus beta squared. Then by these two terms we can take alpha beta out. Gamma squared plus delta squared equals 0. Right. Okay, now you can substitute this alpha squared plus beta squared. You can write alpha plus beta perfect squared minus 2 alpha beta. Similarly, gamma squared plus delta squared you can write gamma plus delta perfect squared minus 2 gamma delta, like this. Then you can substitute for gamma plus delta, alpha plus beta, alpha beta, gamma delta product by those. X squared gamma plus delta there 2q, alpha plus beta 2p times x. Here gamma delta p squared, alpha plus beta perfect squared means 4p squared, 2 alpha beta means 2q squared, then alpha beta q squared, gamma plus delta squared means 4q squared, minus 2 gamma delta is 2p squared equals 0. Then we can simplify this. X squared minus 2 to 4 p qx. Okay. Right now, we can simplify this. Final answer coming in terms of yes. Right here. We'll remove the bracket here. 4p4 minus 2p squared q squared 4q4 minus 2q squared p squared, right? Then we get x squared minus 4pqx. Here minus 2p squared q squared minus 2p squared q squared is minus 4 p squared q squared. Take 4 out. p4 minus p squared q squared plus q4 equals 0 is the required answer. Another one more given there. And that both these roots are imaginary. Of this equation, the both roots are imaginary. So then we have to check its delta. We'll check the delta of this. Okay. Delta of the last equation we obtained. We need to show that is the roots of this last equation are imaginary. Right, that can easily be shown by checking the sign of discriminant of this. Delta equals b squared. B is there, minus 4pq. B squared minus 4 times a is 1. C is this part. 4 times within bracket p4 minus p squared q squared plus q4. We'll check the sign of this. Then here we get delta. Here 16 p squared q squared. Here also 16. Take 16 out. Then here we have p squared q squared minus p4. Remove the bracket by multiply minus sign. Plus p squared q squared minus q to the power 4. Okay. Right. Then we get there okay. Now we'll take here minus sign out, then p4, this will be plus, this and this both will be this way, right? This is q to the power 4. You know this we can write how? Delta minus 16. This is nothing but this part p squared minus q squared to the power 2. You know p and q are not equal. Therefore, this bracket will not be equal to 0. Since here we have perfect square, this is obviously positive. Since here we have negative, that negative and this positive make negative, then delta negative. Delta negative means the roots of this equation are imaginary. Therefore, the roots are imaginary. Roots are imaginary. Right. Next one asking shows that fx plus gx greater than or equal to this. Fx plus gx. We'll see what is fx plus gx. Right. Fx plus gx. Right. Fx and gx, when you add, x squared minus 2px plus q squared is the fx. Gx is x squared minus 2qx plus p squared. Then fx plus gx going to be x squared 2x squared, right, minus 2px, take minus 2 and x out. This way we can write. And we get next one, p squared plus q squared. This is our fx plus gx. Take this 2 out, then x squared minus p plus q times x plus p squared plus q squared by 2 we get. Then we'll complete the square inside the bracket is x minus p plus q divided by 2 of x squared. You know how to complete the square there. From x squared we take only x. We divide this x coefficient by 2, taking them into a bracket, we square that, and we subtract the perfect square of this. P plus q divided by 2 perfect square. After that we have this. This way. Now we will simplify this. X minus p plus q by 2 perfect squared. When you take here the common denominator as 4, this and this both should be multiplied by 2, no? Because here we get 2 squared 4 as a common denominator. This one change. Minus p plus q perfect squared mean p squared plus 2pq plus q squared. Inside the bracket. Then I can furthermore write this 2 within bracket x minus p plus q divided by 2 perfect square. Simplify here. 2p squared minus p squared is p squared minus 2pq. Okay. 2q squared minus q squared is q squared by 4. Is what we get. Right now, we can remove the bracket by multiplying 2. Then we get fx plus gx in the left hand side is equal to 2 times x minus p plus q by 2 to the power 2. This one I can write when you multiply by this 2. This 4 becomes 2. This is p minus q perfect squared by 2. They know p minus q perfect squared by 2. So you know this is a perfect square. No, this one. Perfect square is always either positive or 0, greater than or equal to 0. Right. This is a fixed value. When this perfect square will be equal to 0, then 2 into 0, this will be 0. Still, this value available here. So therefore, the minimum value for this right hand side, it can take is this. Once this become positive, the right hand side will be increasing from the minimum value starting from this. Then the right hand side statement gets the minimum value this, and the other values are greater than that. So therefore, since that is equal to fx plus gx, we can say fx plus gx greater than or equal to what? This p minus q perfect squared by 2. That says the minimum value is this. That's what we have to prove. That's the question number 1. Right, question number 2, part A, the limit question. Right. Question number 2, part A. Limit x going to 0, one minus cos pi x by 8 divided by x squared times x plus 1. Asking to show this is equal to pi squared over 32. Right, now I can write this limit x going to 0, 1 minus this cos pi x by 8 I can write using cos A formula, half angle formula, 1 minus 2 sine squared. This angle should be divided by really 2. There we have pi x by 4, no? Right. In the question it is pi x by 4. In the question here we have pi x by 4. Then when we divide this by 2, we get pi x by 8 divided by x squared into x squared plus 1. Like this, we can cancel down this. Huh? Right now, I can write this one, limit x going to 0 to sine squared pi x by 8 divided by here x squared into this 1 over x plus 1. This way I can write. Then I write here pi squared. To cancel down this pi squared, I write pi squared here. Also, I write 64 here. To cancel down this 64, I write 64 here. Then what I do next is, this 2 and 64 we can cancel down, we get 32 here. Pi squared by 32, that I can take out. Limit x going to 0. This whole thing I can write sine pi x by 8 divided by pi x by 8, right here, pi x by 8, whole thing perfect squared. And the same limit I can apply for this one too. Right. Then you know, as x going to 0, any multiple of x also going to 0. Then this pi x by 8 will be going to 0. Then this takes the form sine theta by theta, theta going to 0. Therefore, this is 1. When x going to 0 here, it's 1 upon 1. Then we get 1. Then we get pi squared over 32 into 1 into 1 over 1. So the answer is therefore pi squared over 32. Yes, it's part B. Find the derivative of sin x with respect to x from first principles that we have done in theory class. Hence obtain the derivative of sin inverse x with respect to x for x less than 1 greater than minus 1. That also we have done. Okay, we'll come to the next part. Y equals sin m sin inverse x dy by dx we can write. First we have differentiated this sign, it is cos m sin inverse x into right, so then m sin inverse x derivative is 1 over square root of 1 minus x squared. Now before going to next derivative, using this thing, use the cross multiplication, root 1 minus x squared dy by dx m cos m sin inverse x. Now we'll differentiate this as a product. 1 minus x squared root we keep as the same. This is the second derivative, d2y over dx2. Then dy by dx, derivative of root first. What is that? 1 over 2 times the same. Right, so far we have differentiated the root sign. Now that should be multiplied by the derivative inside the root sign, it is minus 2x. From right hand side, m is a constant. Derivative of cos is minus sin m sin inverse x multiplied by derivative of m sin inverse x going to be m times sin inverse x derivative is square root of 1 minus x squared. Now this and this you can cancel down, multiplied by root of 1 minus x squared. Then this term, and this term when you multiply by root of 1 minus x squared, what happens is this root will eliminate. That going to be 1 minus x squared d2y over dx2. Once you multiply this middle term by this root, this 2 will cancel off, giving here minus x dy by dx. Right now, and you know this will cancel when we multiply by that root. m and m, this m squared, sin m sin inverse x means sin m sin squared y. So therefore here we get minus m squared y. Bring that left hand side. Plus m squared y is equal to 0. That's the answer. Right, part C. Then you are given x equals 2 sin theta, 2 sin theta plus sin 2 theta. Y equals 2 cos theta minus cos 2 theta. Asking to find the second derivative value at theta pi by 3. We'll first find dx over d theta. It is 2 cos theta. Sin 2 theta is cos 2 theta into 2. Here dy by d theta minus 2 sin theta plus 2 sin 2 theta. Cos 2 theta is minus sin 2 theta into 2. Then by applying the chain rule, we can find dy by dx. Right, dy by dx by chain rule, we can write it's dy by d theta into d theta over dx. Dy by d theta is that it is 2 sin 2 theta minus 2 sin theta. D theta over dx means the reciprocal of this. Then that comes to denominator like this. 2 cos theta plus 2 cos 2 theta. Take this 2 out. You see? Right? And we cancel down now. Then sin 2 theta we can write 2 sin theta cos theta, no? Here sin theta we can take out. We get 2 cos theta minus 1. And here cos theta plus cos 2 theta I can write 2 cos square theta minus 1. Right, now here the denominator you can factorize sin theta is the factor is going to be 2 cos theta minus 1 and cos theta plus 1. Then we get these 2 we can cancel down. Then we get dy by dx. Dy by dx. Numerator sin theta. Denominator 1 plus cos theta. The denominator cos theta I can write using half angles. This also I can write using half angles 2 sin theta by 2 into cos theta by 2. The numerator sin theta you can write. This cos theta I can write 2 cos square theta by 2 minus 1. 1 and this minus 1 you can cancel down. 2 and 2 you can cancel down. 1 cos theta by 2 you can cancel down here. Then we get dy by dx as tan theta by 2. Okay, now let's have a dy by dx. Ask him second derivative. Second derivative, now dy by dx we have as tan theta by 2. Then we differentiate and the once more with respect to x. Then the left hand side we get second derivative of y with respect to x, written as d2y over dx2 like this. Right hand side we must apply that operator like this. Tan theta by 2 this way. But here we have theta, here we have x, then it is not possible to differentiate this. Then we apply the chain rule. Here we write d theta tan theta by 2, and then to cancel down this d theta we write here d theta by dx. Correct. Now here we can write derivative of tan sec square theta by 2 into theta by 2 derivative is half. D theta by dx we can take here 1 over 2 cos theta plus 2 cos 2 theta. Right. Now we'll simplify this. This is this 2 and this 2 you can take out. 1 upon 4 sec square theta by 2 whole thing divided by cos theta plus cos 2 theta. Right. Okay, now this is second derivative d2y over dx2. Right. Right, now asking to show certain answer here. Right, we can write it like this. And now apply theta pi by 3 there. Apply theta pi by 3. d2y over dx2 value we need at theta pi by 3. 1 upon 4 sec squared theta by 2, no? Then pi by 6 cos pi by 3 cos 2 pi by 3. 1 upon 4 sec squared pi by 6. 1 over cos pi by 6 perfect squared. Cos 30 root 3 by 2. Then that goes to numerator 2 over root 3 perfect squared, no? Correct, no? Sec means 1 over cos 30. Cos 30 means root 3 by 2. It's perfect square. That means 2 over root 3 perfect square. Cos 60 half. Right? Cos here minus half coming, no? Right, no? All right. At pi by 3 only asking. Theta pi by 3. Right, theta pi by 3, this answer has no meaning, undefined answer coming, no? Because you know cos 60 half, cos 120. Cos 120 is minus half, right? So therefore denominator becomes 0. This is undefined, therefore, no answer, undefined. Undefined answer coming for that. Cos pi by 3, cos 60 half, cos 120 is minus half. Undefined answer coming there, right? So therefore, The answer is undefined there. Right. Okay. Question number 3 there. Right. Question number 3 gives us in the usual notation, state the sign rule for a triangle ABC. Right. That is possible to do. You can do that. In the usual notation for triangle ABC, show that. Right. We'll see there. We'll take the triangle as ABC. A here, B here, C, simple A, simple B, simple C. A here, B here, C here. And you know, sign rule is what? A upon sin A equals B upon sin B equals C upon sin C is sign rule. Right. Now asking to prove in the usual notation for a triangle ABC, show that this B minus C upon B plus C. B minus C upon B plus C is equal to. Right. Right here, for B and C, we can take here A over sin A equals B over sin B equals C over sin C. If I take it as K, then A over sin A equals K, then K sin A come in. B, K sin B come in. C, K sin C come in like this. Then by this, we can substitute here. This is K sin B, K sin C, K sin B plus K sin C. K can be cancelled down. Then here we have sin B minus sin C. That is, there we can simplify using sin C minus sin D formula. Sin C minus sin D formula is 2 cos. Add the two angles, divide by 2. And sin B minus C divide by 2. And sin C plus sin D, 2 sin B plus C divided by 2 cos B minus C divided by 2. This and this you can cancel down. Then here B plus C by 2. We know A, B, C are the 3 angles of this ABC triangle. Its sum, their sum is pi, 180. Then B plus C we can subject this way. B plus C equals pi minus A. Then I can put that pi minus A here. Cos B plus C pi minus A should be divided by this 2, no? Then this and this both we have divided by 2. Here also the same, sin pi by 2 minus A by 2. Sin divided by cos is here tan B minus C by 2. Okay. Right now, here you know cos 90 minus A by 2 is sin A by 2. Sin 90 minus A by 2 is cos A by 2. Then sin divided by cos means tan. Tan A by 2 tan minus C by 2. Right. This is B minus C divided by B plus C. Right. Using the formula tan A, this show that, yes, right, using the formula tan A, to tan A by 2 divided by 1 minus tan squared A by 2. Right. Using the formula, this show that tan pi by 12. Pi by 12 mean, right, 15 degrees, no? 180 by 12, no? 15 degrees. Then I substitute, put for this angle A 30 degrees. Then here left hand side we get tan 30 to tan here A by 2, no, 15 degrees. 1 minus tan squared 15 degrees. Tan 31 over root 3. I substitute for tan 15 t. 2t divided by 1 minus t squared. What is t? Equals tan 15. This way we put t for our convenience of writing. So now we will bring here using the cross multiplication to root 3t here. Now multiply this by minus sign and bring this to left hand side. Right? Then we get this. Correct, no? Right, t squared plus 2 root 3t minus 1. So now this is a quadratic equation in t. We'll find two answers for this. T equals minus b 2 root 3 minus b plus or minus square root of b squared is 12 minus 4 times a times c divided by 2 into 1. Then here we have t. T equals minus 2 root 3 plus or minus, here we get 16, no? Root is 4 divided by, there are 2. So we can cancel down by 2, we get t equals minus root 3 plus or minus 2. You know, here this t is tan 15. Tan 15, 15 is an angle in the first quadrant, tan is positive. Then we must get the answer for tan 15 positive answer. So because of that, I take this plus sign. Therefore, tan 15 is equal to plus sign when you select 2 minus root 3. 2 minus root 3 is a positive value. Therefore, that is a possible answer here for tan 15. Okay. That's okay. Next one given, hence if b equals root 3c, right? And a equals pi by 6, show that tan b minus c by 2 equals this. Right. Right. We have proved so far this thing, then I can use it. In this I am going to put that b equals root 3 c and keep simplify this. Right. Right. Substitute in this b equals root 3c. For this b we put root 3c because that is given. If b equals root 3c and a equals pi by 6. For this a I am going to put pi by 6. All right. B now root 3c minus c root 3c plus c equals tan, right, A given as pi by 6. When you put here pi by 6, then pi by 12 come in here. Tan pi by 12 is tan 15, this answer, right? Then 2 minus root 3 come in there, right? 2 minus root 3. I directly put that there, right? 2 minus root 3 into tan b minus c divided by 2. Here c we can cancel down. Root 3 minus 1 divided by root 3 plus 1. 2 minus root 3 into tan b minus c by 2. Right now, here I can multiply the numerator and denominator by the conjugate of this root 3 plus 1. Root 3 plus 1 conjugate is root 3 minus 1. No? Then here we get root 3 minus 1 perfect squared. Denominator we get root 3 plus 1 into root 3 minus 1 like this. Equals 2 minus root 3 into tan b minus c by 2. Right, so here we know a plus b into a minus b is a squared minus b squared. A squared means root 3 squared, that is 3, minus b squared is 1. 3 minus 1 is here 2 we get. Here root 3 perfect squared is 3. Here plus 1 minus 2 root 3. We get there. 2 minus root 3 tan b minus c by 2. Here we have 4 minus 2 root 3. Take that 2 out. That 2 and this 2 we can cancel down. 2 minus root 3 we have. That and this we can cancel down. This completely we can cancel down this. Then we get tan. We get 1. Tan b minus c by 2 equals 1. Tan angle equal to 1 means angle should be 45. No? Angle should be 45. Right. Then there we get b minus c divided by 2 angle is 45. B minus c is there. Use cross multiplication 90. We can get number 1. And also this ABC are the 3 angles of the triangle ABC, no? Then ABC sum is 180. Given A as 30, bring that 30 right hand side. Then this is 150. B plus C sum. This is number 2 now. And in 1 and 2, C minus C you can cancel down. 2B is equal to 150 plus this much. Then we get 214, no? Right, then B is 120. Then B 120. Then C 30. A also given as 30. Then of the triangle ABC, the 2 angles A and C are equal each 30. Therefore, the triangle is isosceles. Angle A equals angle C equals 30. Therefore, ABC triangle is isosceles. Right, that way we can take that. The next part. Next part given as inverse trigonometry question. It is tan inverse x plus 1 plus tan inverse x minus 1 equals tan inverse 8 over 31. Okay, this is an angle, no? So therefore, I'll take this angle as alpha. This is also another angle, it is beta. This is another angle, it is gamma. Then we can write tan alpha x plus 1, tan beta x minus 1, tan gamma 8 over 31. Then really, in terms of this alpha, beta, gamma, this equation is alpha plus beta is equal to gamma. I take tan on both sides. Tan alpha plus beta is equal to tan gamma. Expand this. Tan alpha plus tan beta divided by 1 minus tan alpha tan beta is equal to tan gamma. Tan alpha is x plus 1, tan beta x minus 1, 1 minus x plus 1 into x minus 1 is equal to tan gamma 8 over 31. Here these 2 we can cancel down. Here x and x 2x, 31 into 2x is 62x, no? Right, that we can cancel down like this. 2x upon 1 minus within bracket x squared minus 1 is equal to 8 over 31. 2 and this we can cancel down 4. In this we are here 31x. Right. Here people we get 2 minus x squared, bring that to right hand side. 4, 2 minus x squared. Remove the brackets and take to left hand side. Right. Then 4x squared plus 31x minus 8 equals 0. We can factorize this into 2 factors. The 2 factors come in now, x plus 8, 4x minus 1. Correct, no? 4x squared minus 8, 32 minus x, correct. This gives us x equals minus 8, x equals 1 upon 4. But we are given x as positive, right? Given that x positive, therefore this is impossible. Because given x positive, therefore x equals 1 upon 4, right? That's the answer. Okay.